Well, so what would happen if you brought a charged object close to the knob? We did the experiment. We noticed when you brought it close to the knob, the foil still separated, but it was because, not because charge was being transferred, but instead in the foil, the charges were being separated. Because like charges, Nick, repel, and unlike attract, because you weren't actually touching, we have a special name for that. So, charging by induction. I showed you my cool electric wand toy, yes? Yeah. And I got a short video to show you now that we started. So now let's get into it. Charging by induction. So we said charging by conduction. I said, Matt, that conduction requires contact. Charging by induction, electrons in a neutral object temporarily move away from a charged object, but return when the charge is removed. Remember the little electrostatics balloon simulator. There it is. When you rub a balloon on your hair or on your sweater, and then you stick it to the wall is neutrally charged, but you have induced a charge. You have charged by induction, because when you rub the balloon, rub, you get extra electrons from your sweater, and you can see as I bring it to the wall, Mason, you can see the charges on the wall are separating from each other, and I end up with a temporary little positive spot right there. This is called charging by induction. But then as soon as I remove it, the charges return back to where they were. Okay? But you know what? Although normally charging by induction is temporary, we can charge permanently if we're clever. Is that a question? No, never mind. I thought I saw a hand up there. So here's our little thought experiment. You ready? We're going to charge an object without touching it. And this is the basis, although more complicated, Evan, behind either some of the wireless charging they're trying to do, although it's more complicated, or if you have an electric toothbrush that you plug in. The electric toothbrush does not have metal contacts on the bottom because you wouldn't want metal contacts around water. They're using an induction charger to recharge your electric toothbrush. So, two uncharged metal spheres are fixed onto supports and are touching. A charged negative rod is brought in close to the spheres. With the rod still in place, the spheres are separated. The rod is then removed. Show by drawing how the charges are distributed. You know what? Let's draw a little picture. So, before the rod, we have neutral charges. I went 2 positives and 2 negatives on each. We're going to bring a negatively charged rod in. So put some negatives there. We're not touching. We're just going to get really, really close. What's going to happen? Nick, what's the charge on this negative rod? What's the charge on this rod? Negative, you say? So it's going to repel the negatives. Those 4 negatives are going to all end up over here, and the 4 positives are going to end up here. Now, overall, those 2 metal spheres are still neutral, right? But then I'm going to come in, and I'm going to grab the bottom of this sphere, this right here. I'm going to grab the little holder, and I'm going to slide it sideways. So the metal rod is still in place. And I'm going to end up with that. Now I'm going to remove the negative rod. I think I said metal rod. I'm going to remove the negative rod. If I remove the rod, I end up with, and these are now permanent. I have permanently charged the right-hand sphere negatively and the left-hand sphere positively, but I didn't touch them. So with a bit of cleverness, we can charge by induction and actually make a permanent charge. We have to be clever. Does that make sense? Is that okay? Induction is indirect. There is no physical contact. some neat applications. Photocopiers, and I wrote here, see page 261 in your text. I'm going to pause for a second. If you want to open your textbook to page... Nearly done. Let's keep going here. So photocopiers use static charge, page 261. You can read that in more detail. So I have here a reading check. I was going to turn to our lab partner and take turns. We're just going to do this together out loud. So question number 1, I'm not as wild about. It says, what is the definition of an electric force? Well, it's the force that's that occurs between objects of different charge. And in particular, it has direction, because if they're like charges, they're going to, if they're unlike charges, they're going to, that I'm going to want you to know. I would have no problem, Martin, giving you a picture and asking you on your test, hey, what direction will the force act? Will it pull them together, or will it push them apart? You okay with that? Question number 2 says, explain what is meant by an action at a distance force. I'm not really wild about that question, so I'm going to skip it here. According to the laws of static charge, explain how do like charges behave? Nick, now you're not allowed to say it. Everyone else needs to know this. What can you tell me, folks? Like charges will repel. What about opposite or unlike charges? What about neutral objects? How do they react to charged objects? Why? That's the balloon, that's the induction thing. So what, in that neutral object, if there's a charged object over here, that charged object will cause the charges in the neutral object to split up, to move apart, and you'll end up with one side charged closest to the object and one side not. In terms of charge what is electric force proportional to? Number 4, do you remember? It depended on 2 things. The amount of charge, more charge meant bigger force. Distance, less distance meant stronger force. The further apart you got, the less the force. So it's proportional to those 2 things. Who remembers what we measure charge in, the units? Begin with the letter C. Coulombs. Coulombs, that would be a good test question. 1 coulomb, I said, would probably be enough to kill you. A coulomb is a huge amount of charge. A lightning bolt usually has around 15 coulombs of charge. In terms of charge transfer, what's the difference between charging by conduction and charging by induction? Which one of these requires that you actually physically touch the object to transfer charge? Conduction requires contact. Which one of these actually usually is temporary and doesn't require touching? Induction, although I showed you a way, if we're clever, we can make a permanent charge, but that's because I'm a Physics 12 nerd and I had to stick that in. Hey, so when a charged balloon sticks to the wall, does the wall become charged by induction or conduction? Induction, it's a temporary charge because as soon as you pull the balloon away, the charges are all going to spread out evenly. Is that all right? Well, let's finish this off. So, why does a balloon that you have rubbed on your head stick to a wall? I think we've flogged that to death. Just like that. And this is induction. So a negatively charged balloon will stick to a wall because the electrons in the wall move away from the balloon, creating a little tiny positively charged area right there. Right? You can write that down, or if you understand it, then you're fine. I found this online. He doesn't look too happy. Did I have that for you to write down in there? Yeah. Oh, I'm sorry, and I forgot to include it. Okay, I'll pause it. And I got to do something. So we've noticed when I bring a negative rod in close to water, by the way, Ibrahim and Tensei, did the water get bent towards the rod or away from the rod? Towards, got attracted. Okay, so would that suggest that the charges were like or unlike if it was attracted? Which one? Like or unlike? Okay, unlike charges. Okay. So you can try this at home too. Here's your question. So a thin stream of water bends towards a negatively charged rod. When a positively charged rod is placed near the stream, it will bend in A, the opposite direction, B, same direction, or C, won't bend at all. Convince me. Okay, so what you're saying is, originally, if this was negative, don't write this down, I don't think I put this in your notes anyways, then each water molecule, there's a water molecule, what would happen is the electrons would move to that side, and that would leave this side positively charged. And because the positive is closer to the rod, that's why I said electric force depends on distance, because it's closer. Because, by the way, it is true that this negative is going to repel those negatives, but since the positives are closer, the attractive force is stronger. And then, Cole, you're saying if I did the same experiment, but this time the rod was positively charged, then in that molecule of water, all that would happen is the positives would go here, the negatives would go here, and now the negatives are closer, and they'll be the strongest force, and it will be a force of attraction. I agree. I agree. Good thinking. Let's see, I got 40 minutes. Okay, let me just pause for a second here. So, what's your homework? Right now, I'm not going to assign the check your understanding from the textbook. You can complete section 7.2, and then you can work on, your second thing is a take-home quiz. I had somebody ask me a question about the 7.2 homework, so let me go find the 7.2 homework. Blah, 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 blah. Okay, so you guys, apparently the negatives did not photocopy on your handout. Can you make this balloon here negative? Okay, it is. Are there any other charges that, did the wall photocopy as positive?
Yeah.
Okay, so the positives came through. Are there any others, Maddie, that didn't work? Can you see? Are those negative and negative, positive and both? Anyways, okay. So those photocopied, okay. Is there anything else that didn't? No, that works. That works. That works. That works. And then, can you look on the? I guess the last page, Maddie. Are these negatives and positives legible? Those showed up okay? Yeah. Okay, I was a little worried. I didn't think of that when I photocopied these. And then this review quiz, it's big. This is the entire chapter. So right now, I think we can say our test is going to be a week from today. Tuesday next week. Okay? Let me hit pause.